Why do some trucks look like genuine houses on wheels, while others remain simple cargo vehicles? The question is neither superficial nor aesthetic. Just looking at one of these vehicles is enough to notice that something changes. Side windows integrated into a structure that used to be a cargo box, solar panels covering the entire roof surface, a rear door that does not give access to merchandise but to a habitable space with a fixed bed, equipped kitchen, and full bathroom. From the outside, it is still a truck, but from the inside, it functions as a self-sufficient home. However, this is not a large caravan nor a simple exaggerated camper conversion. It is also not merely a trend driven by social media. When a truck begins to look like a house, what we are really observing is a transformation that originates in engineering and ends in lifestyle. These vehicles appear as a response to very specific needs. In Europe, regulations on length, weight, and approval directly shape their design. In the United States, the long distances transform the cabin into a space where the driver can spend entire weeks. At the same time, the growth of overlanding and nomadic life has consolidated a clear demand for real autonomy, beyond simple comfort. But all of that is the visible result. The root lies elsewhere. A truck can become a home because its architecture is designed to withstand heavy loads for long periods of time. Its independent frame, reinforced suspension, and powertrain are designed to move tons with stability and reliability. That structural robustness is the foundation that allows the addition of hundreds of liters of water tanks, high-capacity batteries, fixed furniture, thermal insulation, and complete energy systems without the whole assembly collapsing or compromising its operation. In that context, transforming a truck into a home is not about installing furniture, but about redesigning how masses are distributed, how dynamic balance is maintained, and how a habitable structure is integrated onto a chassis that was originally intended to carry industrial cargo, because not just any vehicle can absorb that level of weight, complexity, and demand without altering its driving behavior, which makes it necessary to look more closely at what makes it possible. What does a truck have that allows it to support the weight, structure, and complexity of a complete house on top without compromising its operation? A truck's ability to transform into a home without losing reliability does not come from size or appearance, but from how it is built from its base, where the true difference lies. Beneath the bodywork exists a structure conceived to work under continuous load, withstand prolonged stress, and maintain stability even when conditions change. This structure finds its clearest expression in the element that organizes and supports the entire assembly. The independent frame formed by longitudinal beams and cross-members whose construction logic differs from the usual unibody bodies found in vans and passenger cars, where the body itself assumes structural stress. In the truck, however, the load is transmitted to a separate chassis that acts as a mechanical backbone. The high-strength longitudinal beams distribute the loads throughout the assembly and allow flexing, twisting, and dynamic stresses to be absorbed without compromising structural integrity or driving behavior. On this basis, when a living cell is installed on top, that structure does not replace the frame nor form part of the main load-bearing system, but rests upon it as just another load within its design logic. This means that the added weight does not alter the vehicle's basic structural function, whose chassis was designed to carry tons of industrial cargo over hundreds of thousands of kilometers, so that the home does not act as an element that forces it, but as a different mass that takes advantage of an already planned capacity. Here, a fundamental concept comes into play, one that is often overlooked, related to the way the vehicle is designed to operate under real conditions. Within this framework, a truck is conceived to work habitually near its maximum authorized weight, which defines its normal operating condition. In contrast, when a van is converted into a camper and water tanks, high-capacity batteries, fixed furniture, and insulation are added, in many cases it begins to operate at the limit of its structural design because it was not intended to withstand such a permanent heavy load, but rather to transport light cargo or passengers. In a truck, the opposite occurs because there is a structural margin that acts as a technical space to add hundreds of kilograms or even several additional tons without compromising reliability or overall stability. It is not only about static strength, but about durability under continuous stress, so that the living space ceases to be a fragile add-on and comes to be understood as a load assumed within the vehicle's original design. To that structural base is added the behavior of the powertrain, which also plays a decisive role, being composed of engines capable of delivering high torque at low RPM, gearboxes with ratios designed to move mass, and cooling systems sized for prolonged efforts. When it transports heavy cargo, it does so for hours, days, or weeks, and if that cargo is transformed into a permanent living space, the mechanical behavior does not change significantly because the assembly continues working within the conditions for which it was already prepared. Outside of that design framework in a van, the scenario is different because the constant increase in weight can translate into greater wear, higher temperatures, and additional stress on the transmission and brakes, whereas in a truck, these systems are sized for their habitual use so that the transformation into a living space does not represent a departure from its operational logic. The suspension and axles reinforce this difference, being designed to support additional tons while maintaining stability and control, so that when a living cell is installed, the center of gravity rises and the mass distribution changes. But the truck's structural base can absorb this shift without losing dynamic coherence, since stability does not depend solely on height, but on how the assembly was conceived from the factory. All of this explains why converting a truck into a home is not an improvised exaggeration, but a technical evolution made possible by its industrial architecture, where robustness ceases to be a desirable attribute and becomes the prerequisite that allows the living space to exist on wheels with safety and durability, without which the project would be structurally inefficient or outright unfeasible. However, the fact that it is possible does not mean there is a single correct way to do it. From there, design ceases to depend solely on engineering and begins to be shaped by the environment in which the vehicle will operate and by the rules it must comply with, giving rise to solutions that can differ markedly between regions. If the base is so solid and versatile, then why are European truck homes so different in design and proportions compared to those we see in the United States? Behind these differences, there is not a matter of taste or aesthetics, but a set of constraints that begin long before the vehicle takes shape within the regulatory framework that defines what can circulate and under what limits. In Europe, legislation does not act as a final formality, but as the starting point that guides every design decision. The European Union establishes very clear limits regarding total length, width and height for heavy vehicles traveling on the road, which directly impacts the truck's configuration. While in other continents it is possible to play with a long nose and a cabin positioned further back, in Europe every centimetre counts, and if the assembly has a maximum allowed length, the habitable space must be optimised within that margin. From this arises the cab-over architecture with the cabin positioned over the engine, a solution that is not a matter of style, but of the need to make the most of the available length, as it eliminates the prominent nose and shifts the usable volume forward. The result is a more compact vehicle with a greater usable surface relative to its total size, something essential in a European truck home to integrate a habitable cell without exceeding legal limits. Furthermore, the European physical environment reinforces this need for compactness through narrower secondary roads, cities with old layouts, and more demanding urban maneuvers, so that an excessively long vehicle would not only be difficult to approve, but also uncomfortable to use, making the compact design a direct response to the reality of the infrastructure. Weight emerges as another determining factor, as the maximum authorized mass sets very specific thresholds that condition both engineering and the driver's access to the vehicle, so that exceeding certain limits implies different driving licenses and greater technical requirements, forcing careful balancing of autonomy, interior equipment, and the overall structure, because every water tank, every additional battery, and every fixed element adds kilograms that must be considered from the start of the project. In this context, the design of the living space cannot grow unchecked. It is not just a matter of whether the chassis can support it, but whether the final assembly complies with the established legal categories. That is why many European projects seek extreme efficiency in materials, interior layout, and energy systems. The goal is not to build the largest possible, but the most optimized possible within a strict regulatory framework. Added to this is the approval process, whereby transforming a truck into a home requires certifying the conversion and ensuring that structural modifications, the installation of fixed furniture, anchors, and gas or electrical systems, comply with specific technical regulations so that periodic inspection ceases to be a symbolic formality and acts as verification that the vehicle remains safe and compliant with current legislation. This administrative requirement even conditions interior design by establishing that not everything that is technically feasible is approvable, so that the layout must adjust to safety, accessibility, and structural attachment criteria, leading to a living space that must not only function, but also demonstrate that it does so within official standards. Height limitations and restrictions on certain roads also come into play, requiring that a European truck home can circulate without being excluded from essential sections of the road network, so that excessive height becomes a practical limitation, just as width does in urban environments, which helps explain why many constructions maintain contained proportions compared to some models seen outside Europe. All of this results in a type of truck home that is more compact, more optimized, and more conditioned by regulation. It is not a reduced version due to lack of ambition, but an intelligent adaptation to a very specific legal and physical framework. Engineering allows many possible configurations, but European regulations draw the perimeter within which they must exist. When that perimeter changes radically, the design also changes. What happens when you remove much of those length and space restrictions and cross to the other side of the Atlantic? Crossing to the other side of the Atlantic, the first thing that changes is not the truck, but the scale of the environment in which it moves. Distances become the dominant reference. Roads are designed for prolonged journeys, and the vehicle ceases to be defined by the need to fit within strict limits and begins to respond to the expansiveness of the territory. In this environment, crossing the country from coast to coast is not seen as an exception, but as a regular part of the job. A driver can spend consecutive days on the road, traversing entire states without returning to a fixed point, which transforms the cabin into more than just a driving position and makes it a space where one rests, eats, and lives for extended periods. From that reality, the evolution of the sleeper begins to take shape, a sleeping cabin that does not arise as an aesthetic whim or unnecessary luxury, but from the real need for the driver to have an adequate space to sleep and comply with driving and rest time regulations, so that when the law requires stopping for certain hours, the vehicle can offer sufficient habitable conditions for that rest to be viable, making habitability cease to be optional and instead integrate as part of the structural design. On that basis, the configuration known as long nose, with the engine positioned in front of the cabin in a prominent hood, facilitates this evolution by moving the mechanics forward and visually separating the cabin from the front axle, generating a larger rear volume that can be entirely dedicated to the habitable space. This layout allows the integration of increasingly deep rear compartments without compromising driving ergonomics. In many models, the sleeper ceases to be simply a narrow bunk behind the seats to become a space with a full-size bed, vertical storage, refrigerator, microwave, and independent climate control systems. In more advanced versions, even compact showers and small bathrooms are integrated as part of a functional logic that responds not to spectacle, but to the real need that, if the driver spends a substantial part of their life inside the vehicle, the space can coherently adapt to that reality. The result is a truck that begins to resemble a small mobile apartment, although its main objective remains the transportation of goods. The difference with Europe is evident. There, design is compressed by strict length limits and more demanding urban environments. In the United States, wide highways and long distances allow the assembly to grow backward with greater freedom. Furthermore, the long-haul transport culture reinforces this evolution. The truck is not just a work tool, it is almost a second home for those who work in it. That cultural perception influences the acceptance of larger and better equipped cabins. What might be considered excessive in other contexts is understood here as a logical improvement in professional quality of life. However, it is important to understand that the traditional sleeper, no matter how spacious, is still oriented toward rest between shifts. It is not conceived for a life completely independent of infrastructure for months. Energy and water autonomy are not the main focus in this type of configuration. The vehicle continues to depend on service stations, rest areas, and established logistics networks. Even so, the step has already been taken. The truck has proven that it can integrate a serious habitable space without ceasing to perform its mechanical function. The cabin ceases to be a simple workstation and becomes a functional domestic environment. This transformation, driven by continental distances and the structure of American transport, lays the groundwork for something even more ambitious. If a cabin can become a small apartment to cross a continent, what happens when the goal is no longer just to rest between routes, but to live completely self-sufficiently for months? Beyond the logic of long-haul transport, configurations begin to appear designed to operate far from any logistical network, where the vehicle no longer depends on service stations or rest areas and is conceived as a system capable of sustaining life in remote environments. It is in this territory that the so-called expedition trucks and extreme overlanding emerge. The leap ceases to be a matter of size or comfort and becomes a structural and operational change. While a professional sleeper remains integrated into a network of established infrastructure, an expedition truck is prepared to cross deserts, mountain ranges, or regions with limited services so that autonomy ceases to be an extra and becomes a fundamental requirement. To achieve this, the mechanical base becomes even more important, because the demand to operate off-road makes many projects start from platforms designed for severe use with all-wheel drive, differential locks, and real capability to face irregular terrain. The ladder frame once again takes center stage, now subjected to different stresses, since off-road driving naturally twists the chassis when overcoming uneven obstacles, a torsion that is part of its design but poses a challenge when a rigid structure like a living space is installed on top. Here comes into play one of the most decisive technical elements in an expedition truck, the decoupled subframe. Instead of attaching the living cell directly to the chassis, an intermediate system is installed that allows some relative movement. In this way, the chassis can flex and adapt to the terrain without transmitting all that torsion to the habitable structure. Without this solution, accumulated stresses could generate cracks or deformations over time. The living space must be protected from the natural movements of the frame, and that protection is pure engineering. To this structural complexity is added the dimension of physical resources, because an expedition truck is conceived to maximize autonomy and space out the need for refueling and external water connections, which leads to integrating large-capacity tanks capable of storing hundreds of liters of water and fuel, as well as provisioning storage systems sized for prolonged stays. All of this increases the total weight of the assembly, although that additional mass is part of the parameters considered from the initial design. The interior, consequently, is organized as a truly habitable space where the bed is usually fixed to avoid daily assembly. The kitchen is prepared for continuous use and the bathroom functions independently, while thermal insulation acquires special relevance given the possibility of facing extreme temperatures, both cold and hot. Overall, every design decision responds to an operational logic aimed not at superfluous luxury, but at creating an environment capable of sustaining life continuously under changing conditions. In Europe, this way of conceiving the vehicle as a habitable space has grown in parallel with the rise of overlanding and intercontinental road trips. Families and couples choose to cross entire countries without relying on hotels or campsites, using trucks transformed into genuine mobile homes. The appeal is not only adventure, but the possibility of real independence. The living space is not anchored to a specific location, but neither does it depend on constant infrastructure. However, all this physical autonomy poses an even more complex challenge. Carrying water and fuel is only part of the equation. A living space needs electricity, climate control, waste management, and systems that function continuously without connection to the grid. The true limit is no longer only the chassis or suspension, but the capacity to generate and manage energy efficiently. If these trucks can go for weeks away from any infrastructure, how do they produce and manage all the energy necessary to function as a real home without relying on external plugs? Total autonomy does not simply arise from having a large vehicle, but emerges from a carefully designed system in which every component must operate without permanent connection to external networks. When an expedition truck moves away from infrastructure for weeks, what truly comes into play is an energy and hydraulic architecture that maintains the balance between generation, storage, and consumption. The starting point within that architecture is electrical generation, where the roof surface of a truck allows the installation of a considerable number of solar panels, far greater than what is available on a conventional van. thus becoming a small mobile photovoltaic plant capable of producing energy for hours whenever conditions allow. However, the key lies not only in how much is generated on a sunny day, but in how that production is balanced with the vehicle's real consumption, because climate control, lighting, the electric kitchen, and electronic systems require constant demand that must be anticipated from the initial design. Consequently, energy storage takes on a central role, with lithium batteries capable of accumulating large amounts of energy in a relatively compact volume. Together with inverters and regulators, they form an electronic assembly that transforms stored energy into usable current for appliances and devices as if it were a conventional home connected to the grid. At this point, sizing cannot be based on optimistic averages. It must account for consumption peaks and prolonged periods of low solar production, because a cloudy day can significantly reduce generation and several consecutive days without sufficient radiation can quickly deplete reserves if the system is not properly planned. For this reason, many vehicles incorporate complementary solutions that act as backup. Reinforced alternators capable of charging batteries while the vehicle is in motion, or auxiliary generators that can be activated in specific situations, form part of that redundancy strategy. Real autonomy does not depend on a single source, but on a coordinated set. Within that same logic of autonomy, water management becomes another fundamental pillar because large tanks allow the storage of hundreds of liters for domestic consumption, a reserve that must be managed precisely to sustain operation over prolonged periods. While advanced filtration systems can expand operational capacity by allowing water reuse under certain conditions, and pumps and circuits must operate efficiently to avoid waste. The living space does not only transport water but actively manages it as a limited resource. Within that same operational balance, climate control introduces additional complexity. Maintaining a stable temperature in extreme environments requires high-quality insulation and efficient heating or cooling systems. In many cases, heaters are used that take advantage of the vehicle's own fuel, thus integrating thermal management into the truck's overall ecosystem. As a consequence of integrating all these systems, each of them adds weight. Solar panels, batteries, full tanks, and technical equipment significantly increase the vehicle's total mass, which raises the center of gravity and modifies its dynamic behavior. That is why energy autonomy cannot be analyzed in isolation. It is directly linked to the structural robustness of the assembly and its ability to manage the stresses that appear in motion. Converting a truck into a self-sufficient home implies assuming technical complexity comparable to that of a small house with independent installations. Nothing is improvised. Each component is integrated into a system that must be reliable, maintainable, and safe over thousands of kilometers. For all these reasons, this type of project is not an impulsive decision. It requires financial planning, understanding of regulations, and an honest evaluation of the real use it will be given. Families who travel for months, couples who work remotely, or adventurers who cross continents find in these vehicles a tool consistent with their objectives, although for other profiles it may prove to be an oversized solution. In the end, the question we raised at the beginning is resolved. Some trucks look like houses on wheels because they have been designed to fulfill a function that goes beyond transportation. They respond to long distances, specific regulatory frameworks, and a growing demand for autonomous mobility. They are not a visual whim or a meaningless extravagance, but the logical result of combining heavy engineering with real needs for habitability and freedom of movement within a demanding context. With all these elements on the table, the phenomenon ceases to be a curiosity and becomes understandable as a perfectly explainable technical solution. The next time you see one of these vehicles on the road, you will no longer view it as something disproportionate, but as a coherent response to specific problems of distance, autonomy, and habitability. If you are interested in continuing to understand how engineering transforms industrial machines into solutions that change the way we move and live, subscribe and join us in the next analyses. Here we continue exploring how the machines that move the world really work,